All right. Well, it's with a heavier heart that I'm here speaking to you. It should have been Laurie. She should be here instead of me on this stage. And if she had been here, she would have told you about all the many exciting projects she worked on and that for which she received that award. She would have told you how she approached her illness as a scientist. She collected data, gathered information, and eventually turned her practical experience as a patient back into science. She would have made you laugh and would have laughed herself with the laughter that anybody who knows her still hears in their mind. So instead, I'd like to honor her with recollections from friends. So, sorry. I want to start by telling you how she touched my life. We met in 1992 at the ICCL conference. ICCL was a computer language conference, which is no more. It was my first paper, and for Laurie it was a banner year. That year she published 9 papers. Nowadays we're blasé about publishing, but back then it was basically never heard of. And at the time I was a young graduate student with very little to show for, no experience, and sheepishly I asked her, would you be on my PhD thesis committee? And she accepted, and she even invited me to McGill to give a talk. And at the time, I was really not sure that this was a path for me, and her encouragement, her kindness, really helped me stay the course. And over the years, I've often remembered. Yeah. Sorry. Yeah. After that, our careers kept intersecting. We've been working on many of the same things. She would start a project first. She would work on virtual machines for Java, and then I would follow. She would do on-stack replacement, and I would do the same. And then at the end, we were both working on array languages, her with MATLAB, me with R, and we would compare notes. Usually I would be the one taking notes. So last time I saw her was in Boston last year. She came to Uppsala to give a talk about her work with cancer patients, helping those who shared her affliction. So this talk is pieced from anecdotes and recollections that I gathered from people who know her, who loved her. Laurie was a role model for many. And she was also the 5 of diamonds. So I will start with a brief overview of her career. She did her undergrad and her master's at the University of Kingston in Canada, and then she went to Cornell. At Cornell, she was the second PhD student of Professor Nicolau. The first was Alex Eichen. A recollection that Alex shared with me is the following. He says, in the 1980s, at Cornell, they had a PhD exam that was composed of 5 tests, and you have to succeed 4 of them to proceed on to your PhD. At some point, a student created a set of flashcards called the cards that were a memory aid for people who were studying for the test. And the student passed it after he or she finished their exam, passed it on. And the cards became part of this sort of secret society. And each class of PhD students, there was one person who would receive the cards, and their job was threefold. They had to, 1, keep the cards a secret. I guess that secret is out now. 2, update them as needed. And 3, most importantly, pass the cards to someone else who met a very specific description. Someone in the next class who deserved to pass, but may not. So Alex says that he received the cards from his future wife, Jennifer, and he gave them to Laurie. At Cornell, Laurie was also known to be a right-winger. I say winger, not wing, because this is referring to a hockey term in Canada. Anne Rogers remembers her enthusiasm for hockey, and she tells us, "It was Jim Russell who convinced a significant fraction of the PhD students to take up ice hockey. We'd play on Friday and Saturdays, starting around midnight and until 2 a.m. We took ice hockey classes when skating for lunch. To say we were obsessed would not be too far off. Many of the women in the PhD program formed a team called the Flying Diskettes." Yes, it is a bit dated. We won the Championship League in 1989. It was one of our prouder moments at grad school. After graduating, Laurie joined McGill University, where she spent the next 30 years, starting as assistant professor, working through associate, full prof, and all the way to associate dean. After obtaining tenure, she took up hockey again. She was a prolific author. She has about 120 refereed papers in some of the best venues of our community. And she was also a caring advisor. She spent much of her time looking after students, advising them. And this slide is a list of her current students, of the postdocs who visited her, and of her successful master's and PhD students. And many of them have contributed to these notes. So some of the distinctions that she's proud of are that she was named Fellow of the ACM in 2001 and Fellow of the Royal Society of Canada in 11 and 12. She had a Canada Research Chair in compilers. She won the Prize de Cancérologie 2016 and the Merck Patient First Award for her work on OPAL. And the whole OPAL team, and I'll tell you more about that, was awarded a prize by the Quebec government on the 31st of May, 4 days after she passed. And at home, she married Prakash in August 1988, when they were both at Cornell. Then, when they moved to Montreal, they had a daughter, Jane, who's now studying at Caltech. When Prakash was elected to the Royal Society, a year after Laurie, at his birthday, a friend recited the following poem. Of our Royal Society, he's a fellow for life, but we'll note that he only got in after his wife. Laurie laughed at that one hard. Her first paper was published in 1984 in the APL journal. And she spent the next 15 years working on C programs, improving their compilation with the MacCat compiler. The work that led to her tenure was shape analysis in the presence of function pointers for the C language. With her student Rakesh Ghia, she designs a points-to abstraction for must and may analysis. That was the topic of their Popple 98 paper called Putting Pointer Analysis to Work. So I will go through 3 of her research projects, and I'll start by mentioning that one of the defining traits of her approach to science was her belief that any scientific result should be backed by software that can be used by others. So it's software that is open source and that is easy for people to pick up and build on. And the SUIT project, which is the first project I'll mention, is a testament to that. It's still used today, 20 years after it was created. As this word cloud shows, this is the word cloud built on the first few years of SUIT. SUIT started as a tool for analyzing Java programs. Today, Soot is part of several commercial products and a number of large-scale deployment in large companies. Another of the unusual facts about Laurie is that she was willing to invest her time in maintaining software artifacts. So it's not an accident that Soot is still used 20 years after it was created. It just doesn't happen like that. And Eric Boden recalls the following. He says, unlike many projects, Soot has an active community for 20 years. Laurie's group and mine have invested dozens of PhD students into it, and others have contributed as well. A big game changer for Soot was Android support. Soot was the first analysis framework to have a good Android support, and it was immediately picked up by hundreds of researchers. Just the FlowDroid extension to Soot alone has well over 1,000 citations. And one of the largest Android App Store operator is using Soot internally. So this is the word cloud that shows the evolution of Soot from a compiler research framework to a widely used tool across many applications areas. The inspiration for Soot came from Laurie's time at Aarhus University. It is there where she first started thinking about object-oriented programming. She gave the first talk about Soot in 1998, and the first publication appeared at CASCON, the Canadian IBM Research Conference, and that paper has over 600 citations. Andrzej Lotak remembers, Soot is Laurie's most well-known work and what she's considered herself her most important contribution. She was taking the research she had done on MacCat for C and seeing how those techniques could be applied for Java. Soot's intermediate representation is named Jimple because MacCat's representation was named Simple. Laurie spent a lot of time discussing APIs with her student Raja, and it's no surprise the project became so successful. She paid attention to detail. Eric Boden adds, I think Soot's major success factors are Jimple and good maintenance. Jimple is a great IR, and the attention to detail made all the difference. So after spending time on Soot, Laurie switched topics and looked at aspect-oriented programming. And she worked on the ABC compiler, the Aspect Bench compiler. And ABC was a compiler for the full Aspect-J language. And it had two front ends. One was using Polyglot for extended Sybil compilation, and the other one was using JustAdd. And it had, of course, one backend, and that was Soot. Right? So she herself would build on the work she had done before. And ABC was a joint project with the tool groups, the programming tools groups at Oxford University, and their paper at the AOSD 2005 conference summarized the achievements in that project. Then, after a few years on aspect-oriented programming, Laurie came back to her first topic of scientific investigation. Remember, I told you the first paper was in the APL magazine, and so she went back to array programming and looked at MATLAB. And the SIGPlan blog has a recollection of that project, which reads, Laurie's history of creating long-lasting research infrastructures culminated in her last project. The work was motivated by discussions with domain experts, where she noted that environments like MATLAB were frequently closed source and hard to use. And she was interested in opening them and making them open source. And this is how she went on to build MATLAB. So it built an open source, scientist-friendly scientific computing alternative and had advanced optimizations for dynamic array-based languages. The project started in 2010, and since then, over 24 students have written theses and been involved in the research. And the last, so this is the last bit that I want to talk to you about, is Opal. So Laurie's work on Opal started after she was diagnosed with cancer. And from the Opal tribute, it tells a little bit of the story. So she met Dr. Hijal, who is a radiological oncologist, and he introduced her to John Kildea. And together, all three formed the core team for Opal. Then Laurie enlisted 15 McGill students to develop the software. So what is Opal? It started with a portal with information about waiting times, because Laurie found that often as a cancer patient, waiting in the sort of to be received was one of the stressful experiences, and reducing that stress was something that she cared about. But soon it became a full-blown app that provided blood test results, predicted appointment times accurately, allowed check-in, virtually eliminating long lineups and reducing anxiety-ridden waiting. Laurie was uncompromising in her insistence that patients should have access to their medical data. She pointed out the numerous benefits this can bring to both patients and clinicians. Opal is now being used by almost 200 patients at Cedar Cancer Center. So, with this, I conclude my prepared remarks, and I would like to ask for 2 minutes of silence while I'll show you some of the remembrances that have been shared with me. Okay. Well, I'd like to thank you for your attention, and maybe we could applaud Laurie as if she had been here to receive that Dahl-Nygaard Prize that she well deserved. Thank you.